Hello, welcome to Electronics Education. This is Vincent Chang. Today we are going to continue our learning around the classical transistor amplifiers small signal analysis. Bipolar junction transistor emitter follower, part 1, based on high BJT model. So this circuit shows an emitter follower or common collector. Emitter follower, since the collector is AC grounded, so it's also called common collector configuration. So emitter follower, so signal coming in from the base, and then the output signal is taken from the emitter. So base in, then emitter out. Base in and emitter out. High BJT model. So signal source, Vs. Let me try to just draw the small signal equivalent circuit. So RS, RB, and base terminal. And then high BJT model, base emitter collector. The resistance between base and the emitter looking into base, R pi. Current control, current source, beta times IB. And the emitter current is the IB plus beta IB equals 1 plus beta parenthesis IB. And now the collector is grounded. It's the AC grounded. And then a parallel resistors, parallel combination between RE and the RL is connected between emitter and ground. The first parameter I want to ask is the input resistance. The input resistance looking from the right hand side of the signal source resistance RS. So Rin. In other words, the effective total input resistance of the red block, the red highlight. So the Rin should be equal to Rb, capital B, in parallel with Ri lowercase b, Rib. And then what's the Rib? It's the effective input resistance of the green block. So the Rib should be equals to the series combination between two things, right? The first one is R pi. The second component is the parallel combination of the Re and the Rl. But watch out this. Be careful of this. Since these two components, the current are the same, are the current flowing into these two bodies are the same? No, they are not. Because the current flowing through R pi is what? Is IB. But the current going through the second component is the first component's currents, how many times? The 1 plus beta. So we need to reflect the difference between these two currents. So 1 plus beta. So here's the answer. So R pi plus the parallel combination between Re and Rl times multiplied by 1 plus beta. So voltage gain. So voltage gain, VO over Vs. VO over Vs. The first component is the VB over Vs. It's the divider between Rs and the Rin. And then the second component, VO over VB. Let's watch the numerator. So the VO is what? VO is the current times the resistance. Current times the resistance. And what about the denominator? The VB is the IB times the resistance between base and the ground looking into base. So which is the IB times Ri lowercase b. IB times the Ri lowercase b. So IB can be canceled out. Then here's the answer. I'm not going to belabor the details, so you can just maybe pause and take note and try to digest. And then what's the RIB? So RIB is what I just mentioned above, right? So here's the total overall VB over VS times the VO over VB give us the final outcome. The overall voltage gain, VO divided by VS. So here's the takeaway. The two parameters we have analyzed for the emitter follower. The first one is the input resistance. The input resistance, R pi, the series component, remember this, I try to just analyze this based on the analysis by inspection built around the hybrid model. But I don't draw out the hybrid model. So it's pictured in my mind. Okay? So I expect you can also picture hybrid model in your mind by looking at the circuit. So the Ri lowercase b, the IB is what? It's the R pi, right? R pi. In series with the parallel combination of Re and RL. But due to the current difference, the IB 1 plus beta times IB. So you need to reflect. From the emitter, reflect to base. Back to base have to be multiplied by 1 plus beta. And then for the voltage gain, VO divided by VS can be split into two parts. VO over VB, which is the second term of the voltage gain expression. And then VB over VS, which is the first term of the voltage gain expression. So this result tells us the two important characteristics of emitter follow. I want you to remember. Number one, very high input resistance, right? A very high input resistance. Number two, so you just look at the math. If the input resistance is very high, then what? Then the first term is less than 1, but close to 1, right? Also, the second term is less than 1, but close to 1. So the emitter follower means the output signal can follow the input signal, follow the input signal's phase, and follow the input signal's strength, which means the voltage gain for the emitter follower is very close to 1. It's less than 1, but close to 1. This is the takeaway, the end of the lecture. Thanks for watching.